Afternoon, everyone. Welcome to this afternoon's presentation. This is a public lecture that's actually being hosted by not just the Data Science Across Disciplines Research Group within the IFK, but also the Department of Mathematics and Applied Mathematics at the University of Johannesburg. Our chair for today will actually be Dr. Mba, who is a lecturer in the Department of Mathematics and Applied Mathematics at UJ. He obtained his PhD in mathematics and group theory in particular at the University of the Western Cape. And now he conducts research in the fields of data analysis, portfolio selection and optimization, and also in financial economics and financial mathematics. So Jules, please, will you take us away?
Okay, thank you very much, Paris, for this short presentation. Yeah. All right, today's seminar, we are going to have a team from Opti-Num Solutions, MathWorks. They are going to take us through machine learning with MATLAB. MATLAB is a computing platform widely used by engineers, scientists, and financial practitioners, right? And they will apply a variety of machine learning techniques with focus on applying ensemble of regression trees to illustrate the forecasting of 10 days volatility of Bitcoin. And this illustration will demonstrate the simplicity of implementing a MATLAB workflow to solve a complete machine learning problem. And they are going to take us then through the process of data acquisition, pre-processing, model building, and validation. And they are going to also share with us some website where we can access learning tools for MATLAB, programming, and also machine learning. And okay, the application on Bitcoin, yeah, we can all know that yeah, Bitcoin is really making mainstream news these days since 2008, and it is holding ground, and it is really it has become a very well asset in the financial market. And I think that is why it was a good thing for our team to think of, applying their method or the machine learning techniques into the Bitcoin. Let me introduce our two speakers. I'll start with Ms. Hazel Chieza. She's a graduate engineer at Opti-Num Solutions. She has completed various software engineering projects such as automated and KPI reporting using MATLAB. Additionally, she provides technical support on MATLAB and Simulink Products. She has published in the field of optimization and quantum computing. She is completing her MSc in Computational and Applied Mathematics at the Wits University. And our second speaker will be Dr. Marco Rossi. He is an Edu Customer Success Engineer at MathWorks. He supports academic and researcher in the use of MATLAB and Simulink for their research and teaching activities. He holds a doctorate in mechanical engineering from the Dresden University of Technology in Germany, and his research interests are theoretical modeling and numerical simulation finite elements of soft material such as polymer and smart gels. The presentation, I think we are going to take like 1 hour, 10 minutes to listen to their presentation, and remaining 20 minutes we can have question, answers, comments, and any just discussion that may arise. Okay, I will give the floor to our speakers to start their presentation.
Thank you for that insightful introduction, Dr. Mba. So my name is Hazel, and today I am presenting alongside Dr. Marco Rossi. And let me just start by saying that I'm extremely excited to be presenting on MATLAB's AI capabilities. I actually started learning MATLAB. It was the very first programming language that I actually learned when I was in first year, and I was so intimidated by MATLAB. And back then, we would actually open up Linux terminal to actually run MATLAB, and I couldn't even figure that out, let alone actually code in MATLAB. So believe me when I tell you that I'm so happy and so excited to be presenting on MATLAB's AI capabilities. So if there's anything you guys get from today's presentation, I really hope it's the courage and the knowledge to actually take on any programming language. So on the next slide, I am currently a graduate engineer at Opti-Num Solutions. I recently completed my honors degree in mathematical sciences. So my modules are geared towards applied mathematics as well as data analytics. Currently in my role at Opti-Num Solutions, I have been exposed to a variety of projects, and good thing that most of them are problem solving. They're quite problematic problems. So yay for me, applied mathematician. I am presenting alongside Dr. Marco Rossi, and he is part of the MathWorks academia team. And I'm sure he'll tell you all about his incredible portfolio, but essentially Marco works alongside Opti-Num Solutions so we can develop and present these innovative and informative presentations around what MATLAB is and what you can actually do with MATLAB. So on the agenda for today, I am going to take you through a quick introduction about who Opti-Num Solutions is and what it is that we do, as well as who the MathWorks is and what they do. Marco is going to take you into a detailed discussion on artificial intelligence within the MATLAB environment. I will come back with a demonstration where we'll actually use these AI techniques on an actual Bitcoin volatility and industry problem. And finally, we'll conclude by just going through some of the techniques and tools that you guys can actually use to get started on using MATLAB. So who are we? So essentially, Opti-Num Solutions is a redistributor of MathWorks products, and the MathWorks is the official developer for MATLAB and Simulink products. There are quite a few distributors around the globe, but Opti-Num Solutions is based in Southern Africa. We are the sole redistributor of MathWorks products within the Southern African region. But beyond that, we do offer a wide range of services to different universities, as well as many different companies in different industries. Some of these services that we do offer include technical support, as well as training on MATLAB and Simulink products. We also do a lot of consulting work where we work hand in hand with a lot of clients to develop innovative and producible solutions using, amongst many other things, MATLAB and Simulink. So quite a few of our projects are data analytics based. So we do get to implement all of the cool stuff within AI space using MATLAB to solve these problems. So without waiting too long, I would like to introduce Dr. Marco Rossi so he can take you through some of the things that we use AI within MATLAB, within the MATLAB environment.
Perfect. Thank you so much, Hazel, for the introduction. So I will guide you toward, let's say, the second bullet point of the agenda, that is AI with MATLAB. Let me welcome also everyone in the audience. Let me thank you, Professor Harley, Professor Momonia, Hazel, and all of you, also Dr. Mba, for the organization of this event. For me, it's a pleasure being here and talk to you about some of AI, artificial intelligence, that is actually changing the way we live, and it will change the way we will live in the future. But before to have a deep dive into artificial intelligence, let's start with MATLAB, just to give you a panoramic view of this tool. Actually, MATLAB, if we want to answer the question, what is MATLAB? Well, MATLAB is a programming and numeric computing platform used by millions of engineers and scientists all over the world to analyze data, develop algorithms, and create models. And here you have a snapshot of, I don't know how MATLAB looks like, but let's play a video. In order to show you that MATLAB started as a vectorial calculus tool, today developing something more advanced with thousands of functions and apps, as you can see here in this part of the video, where you can analyze images, control your parameter, understanding the answer of your model, analyze your signal or your plot, and simulate robotic systems. And again, it's something, let's say, more advanced with thousands of functions, many field-specific application, and also interactive notebook that I will explain you just in a second. Interactive notebook are called live editor. Is something very helpful because it allows you to create your code, embed in the code text. So you can create a narrative around that code. And this can help students, for example, when a student is trying to learn something, because you can manage to read the theory and play with the model, but also among researchers, because the way they share the code is becoming very helpful thanks to the live editor. Live editor can then be exported in different formats. We have PDF, we have Word file. You can also include your LaTeX formulation for those of you which are familiar. Let's try to understand better what it is a live editor, because later Hazel in the demo about Bitcoin will use a live script. So actually we are familiar with the line of codes in different programming language. It's just the semantic that is going to change, but you have line of codes with the specific output, which can be a plot or an array or whatever you like. With the live editor, you can add a text, like a title, like, for example, the subtitle. You can add a bullet list, and maybe why not? Here there is a formula. So what about to add maybe a picture that describes that, and below the picture add the formula, maybe with a LaTeX equation that we can bring from, I don't know, one of our publications. At the end, we have something like that. So we have a narrative around our code. We have the theory, we have the formulas, we have the code. And we can actually play with the code, because we can hide the code and then just have, let's say, the theory and what you have seen the controller. MathWorks developed not only MATLAB, let's say, what we have seen before that, let's say, it's the main platform, but there is a much more. The much more consists in more than 350 toolboxes and add-ons which are developed by MathWorks, and you can rely also on 40,000 toolboxes and add-ons which are developed by the community. Let's give a look to that. At the end of this talk, we will share with you the slides. You can navigate in these slides. There will be many hyperlinks that you can watch. The first one is MathWorks products, just to understand the amount of products. You can see here I'm on the MathWorks website now. There are the two main products, which are MATLAB and Simulink, and then there are field-specific toolboxes which you can use in order to solve your problem. Today, we will see statistics and machine learning toolbox, for example, and here you can have an overview with a video, with, I don't know, some applications of this particular toolbox, but there are many others, which goes from database toolbox, from code generation, and also some application-specific toolbox, as for example, computer vision, 5G toolbox, UAV toolbox, and so there are really a lot. Just to have you a view of how many applications there are, just give a look on this page. Let me go back to the presentation in order to go ahead and just talk to you about the technical computing workflow. What it is, what I wrote here is that different problems, one workflow. What does this mean? Actually, in MathWorks, we like to use a lot this workflow because we believe that this can describe the way scientists from all disciplines work. On the left-hand side here, you have the starting point that is usually data which may come from different sources, files, software, hardware, instrumentation. For example, today we will start our demo with Hazel that we show you the way to acquire data from file, in particular from the web. And then you have the central part, because depending on your data and your objective, you may want to do some signal processing, model and simulation, data analytics, statistics, machine learning. We do today machine learning, so we are in this box here where we do some algorithm development together with machine learning. Finally, when your problem is done, you may decide to export your data and maybe report and documentation. We have seen later that your live script can be exported into PDF. Maybe you want to share with your research partner from another university, or maybe if you're a student, you want to share your project with other students, with your colleagues. All right, and now that we have done, let's say, an overview of the tools, of some of the tools of MathWorks, and let's say the most important that we will use later on, let me introduce you to artificial intelligence, a topic that maybe for some of you is already well known. Well, artificial intelligence is a mega trend. Origins date back to the dawn of computing, that evolved in 1950s, and then let's say developed toward machine learning, and today toward deep learning. So neural networks which have been inspired from, let's say, the human neural network. This is just an inspiration. Finally, the two systems works pretty differently. Anyway, this is the trend, this is the timeline of the evolution of artificial intelligence and the sub boxes, machine learning, and then within machine learning, deep learning. Integrating artificial intelligence is a priority for many companies, but also for many research departments. But behind the hype and a few, let's say, popular applications, for the majorities, it turns out that the reality that this can be quite hard to do. There are challenges. I like to show you this survey by Gartner in 2020, where they reveal some of the reasons, some of the pains which researchers, let's say industry, are experiencing about the AI integration in their workflow. Where you see the top barriers here. The first is integration with the existing technology. The second is the complexity and the quality of your data. And then the lack of skills, because sometimes what happens is that, for example, at the department, I don't know, science, natural science has to deal with artificial intelligence, so there is not the right overlapping of skills. What we are doing at MathWorks is start to collect all these informations which come from industry and academia. What we are hearing is about where we will link the real system and AI, or maybe we would like to combine the workflow with multiple vendors which are actually using maybe different programming language and different applications or software. Maybe from academia, we got this feedback about, I want a robust solution I can maintain, because sometimes, yeah, this is not the case. Well, by collecting all this information, MathWorks today is recognized as one of the leader platform to perform data science and machine learning according to the Gartner Magic Quadrant. This is the one of 2021. We were in this classify also for 2020. And there on this website, if you Google it, you can understand also the differences. So let's say the positive and negative aspects of using a different tool. So MATLAB has been developing for 35 years, and over the years there have been a significant investment, especially in understanding the need of researchers and industry in both engineering and science. Yeah, in this way we want to enable them to perform the latest research and realize them the next generation product. Application of artificial intelligence together with MathWorks and in general MATLAB embrace different fields of application. Here you can see text analytics, audio processing, I don't know, image processing, LiDAR processing. There are really a lot of application. In the next, I would like to focus on computer vision that you can see here on the left-hand side, and then here on the bottom right-hand side, there is a sensor data analysis. So let's give a look a little bit more in the details. So here there is this example of deep learning detection using the YOLO version 2. YOLO is also a very nice song by the Strokes, but here is you only look at once version because it's a kind of deep learning algorithm embedded into NVIDIA can recognize speed limits and let's say road signals in general. I leave you a link here on the bottom. If you click on this link, you can have access to the full tutorial, which explain you the way and the workflow to actually implement this kind of YOLO for let's say road signal detection. All right, on the right-hand side, we have a signal classification. In particular, here it's using and classifying the human activity. Here you will see a plot with the time here on the x-axis and the acceleration. There are 3 lines because there are 3 components of the acceleration, x, y, and z. And actually, what this algorithm is doing basically is try to understand the, let's say, the peaks of the acceleration and understand if I'm standing, it's a little bit flat, or maybe if I'm lying, some of the components change. If I'm walking, of course, there is high frequency content in my signal, and then I can understand also according to the component of the acceleration if I'm working upstairs or downstairs. Again, here this is a tutorial, an example that you can follow step by step in order to understand what's going on in this video. All right, here I want to show you some application that, for example, I'm collaborating with as member of the MathWorks academia team. On the first row, we see some collaboration with the university. We have the University of Twente that is developing augmented reality of blood vessel, blood flow. We collaborate also with the German Cancer Research Center in the field of using deep learning for tumor detection, while on the second row you see some, let's say, very famous industrial partners as Airbus, BMW, and Shell, which are using artificial intelligence in MATLAB to face different problems, from automatic defect detection at Airbus to oversteering detection at BMW, and finally seismic event detection. That's very important from some, let's say, platform of Shell as in some remote areas. All right, but why we should use MATLAB? Why this research institute? Why these industries decided to use MATLAB for their application, for the artificial intelligence code? Well, during your journey, you will have many benefit out of the things that maybe I will explain you right now. The first thing is that one of the most important component, it's people, the human factor. At MathWorks, you have a dedicated team that will be always happy to support you and to guide you toward understanding the workflow that you'd like to use for the specific problem that maybe you are going to have in your, let's say, industrial or academic framework. Another thing is the productivity. We have different, let's say, solutions to speed up your code and to also let them well integrated with other platforms. We have a specific workflow for engineering and science. We have seen different toolboxes before, each of them specific for disciplines. And then also interoperability, because MATLAB speaks other programming language, and you can really easily integrate, if we are talking about artificial intelligence, maybe algorithm developed in TensorFlow or PyTorch, because MATLAB support the ONNX standard. And finally, also the deployment of your algorithm on applications and system. There is a workflow that will guide us toward, let's say, the data preparation, to the development of the AI modeling, to the system design, and then to the deployment. We will see this workflow later with the Hazel talk, where she will show you the demo about volatility of Bitcoin forecasting. And you will see also some of these, let's say, key takeaway and benefit that you can have in using MATLAB for artificial intelligence. Let me give you a rapid introduction on this workflow. Let's spend some word on each of these blocks. Let's start with the data preparation. You have one environment that is MATLAB, where you can work with different data sets. Not only numbers, it could be text, signals, and images. The second step of the workflow is the development of your algorithm. And for machine learning, an example could be to use an app, in this case, a classification learner app. An app is a graphical user interface that can let you save a lot of time in case of you don't want to write a full code to solve a problem. At the same time, it would be very useful for all of those which are not familiar maybe with the programming and write the line of codes. All in all, there is always the possibility to interchange between the app and the language. Everything you do with the app could be done, converted into line of codes, just touching a button, and where you can generate the code for your app. But let's see, how does an app look like? This is the classification learner app that imports your data. You can navigate throughout your data, import them, and then use an algorithm, many algorithms actually of machine learning, which are already implemented into MATLAB, and you can use all these algorithms to train your data and understand the best one according to your specific data. I will stop here. Later on, Hazel will show you the regression learner app, which works similarly. So you will see also in action the way to use this app. Still into modeling, we know that the broader AI community are developing a new model all the time, and not all of them are using MATLAB. They can be using Python, for example. But MATLAB support the ONNX standard, so you can have access to all those models which maybe some other research lab or some of your colleagues has developed with, I don't know, TensorFlow or TAFE2 and so on, and you can import maybe into MATLAB in case of you want to do something in particular there. So interoperability will be a concept that I will recall also at the end of this talk. All right, now we are at the third step of the workflow. Once you have your algorithm of artificial intelligence you want to use to tackle a problem. In this case, the problem is an engineering problem about predictive maintenance that is about to inject some fault into your system. And this is a Simulink and Simscape, which simulate a mechanical system, a triple pump, as you can see, where, I mean, I don't want to inject fault in my real pump. If not, I will destroy it. I want to have this failure condition in a simulated environment. And I can do this with MATLAB and Simulink in this case, while performing the simulation, embed my artificial intelligence algorithm, which will be capable of reading the data and let me know, stop, maybe you are going to face a failure in 1 week. That's a typical problem of predictive maintenance. Finally, the last step of the workflow is the deployment. And again, there is in MATLAB a unique code generation framework that allows model developed in MATLAB and Simulink to be deployed in an optimized way in order to be then used on other platform. Automatic code generation in MATLAB eliminates coding errors, and it's an enormous value driver for any organization which is adopting that. So, what are the key takeaways that I wanted to communicate to you in this first time? Well, you can analyze your data with a reduced time and effort thanks to the apps. Apps helps you also in developing your artificial intelligence model. Interoperability can easily support collaboration and sharing your code. And then finally, the deployment on embedded edge devices, and also into the cloud or desktop system. But I mean, apart from the theory, we would like to see an application, and that's why now I give the stage to Hazel that will demo for you the forecasting Bitcoin volatility example. Hazel, the stage is yours for the demo part of this talk.
Thank you so much, Marco. Thank you, guys. So this is the typical layout of MATLAB. There is a workspace, a command window. There's some folders you can select. There is a panel where you can actually write your code in. So like Marco mentioned at the beginning of his presentation, the idea of a live editor, I'm actually going to be using a live editor to present this demonstration to you. So for visualization purposes, I'll just make that the focus of the screen. Today's aim, or the aim of today, is to actually build a machine learning model that is going to forecast or predict the volatility of Bitcoin. So before we get into that, we can just have a quick discussion on what Bitcoin actually is. So Bitcoin is a digital currency, or just a cryptocurrency. And one of the reasons why it's so popular is because it's decentralized. So it's this idea that there's no central bank or there's no entity that controls the supply and redistribution of Bitcoin. So essentially, Bitcoin's value is derived from its demand. The more people that actually demand Bitcoin, the more valuable it becomes. I'm not sure how many people keep up with the finance news, but a couple of weeks ago, Elon Musk, he came out and he mentioned that Tesla would no longer be accepting payments, or Bitcoin would no longer become an accepted payment method at Tesla. And around the same time, there were governments that were actually cracking down on banks that were engaging in Bitcoin transactions. So this essentially shrunk the pool of what you can do with Bitcoin, and it led to this big drop in the value of Bitcoin. So essentially this presentation or this demonstration is interested in finding out or predicting what points in time we can actually expect to see such fluctuations, especially such dramatic fluctuations in the price of Bitcoin. So typically Bitcoin was originally, it wasn't quite a professional currency. It wasn't really something that people invested. It was more like a hobby. But recently, we've seen quite a few professional money managers actually including Bitcoin in people's portfolios or investment portfolios. So this just puts into perspective just how important the volatility of Bitcoin is, and how the example we're going to do today is actually an industry problem. So we're going to look at a simple 4-step machine learning workflow, which consists of importing your data, pre-processing the data, building a machine learning model based on this data, and then evaluating the performance of the model. So we're going to start with importing the data. So typically your machine learning models depend on your data. And as such, we need quite a bit of data to actually get a well-trained model. And most importantly, we want data that's from a reputable source. So for the purpose of this demonstration, we're actually using Quandl, and Quandl is a platform that has a lot of financial as well as economic data sets. There are other kinds of data sets, but Quandl's main focus is on the finance and economic data sets. And this is the platform that we'll essentially use to get Bitcoin data. So before you can actually extract data from the Quandl servers, you need what we call an API key or a web API key or a Quandl key. And to do this, you can actually sign up on the Quandl website, create an account, verify your account. This is all free, so you don't have to subscribe or anything. But I just want to show you a visual depiction of what Quandl actually looks like and how you can actually obtain your Quandl key. So this is the interface of the Quandl servers. So if you go to the top right-hand corner, there's a figure. If you click on that and actually go to account settings, you'll be able to actually get your Quandl key. You can copy that and actually paste that onto your MATLAB environment. And essentially what that does is it creates a connection between the Quandl servers and your MATLAB platform. So now you're in a position to actually extract data from the Quandl servers. So now that we've created this connection, we can actually decide or choose which variables or which data we actually want to extract from Quandl and use within our MATLAB environment. At this point, we usually ask the question, what are some of the variables, what are some of the features that actually impact the volatility of Bitcoin? And if you don't have much domain knowledge, then you can just do a quick Google search and you'll be able to find out that things like Bitcoin's market price, the total transaction fees of Bitcoin, as well as the Bitcoin market cap, are just some of the variables that actually impact or influence the volatility of Bitcoin, some indirectly and some directly. So once you've actually defined these variables, you can now go through the process of actually extracting these particular data sets or these particular features and variables from the Quandl server, and you can actually concatenate them into one table, which we see below. So you'll notice that I'm not necessarily going into what the code is doing. This is because I understand people have their own way of programming things, but I just want to bring your attention to some of the built-in functions that we use to actually extract this data from the Quandl server. And a particular one is the history function. So MATLAB has an entire toolbox or entire library that has many different built-in functions where you can use to extract data from various platforms. And what's really nice about MATLAB is if you had to highlight this function and right-click on it and go to help, a pop-up function or a pop-up bar would come open and you'd be able to see some of the information pertaining to that built-in function, as well as some examples. So this is one of the nicest things about MATLAB is everything is kind of localized. You don't have to exit MATLAB to go and look on the website or on Google to actually find out some of the documentation. So everything's nice and localized. But anyway, just back to the example, this is the table that you'll get. And at this point, I just want to make note that we haven't actually changed any of the variables. We haven't manipulated the data in any way. We've just extracted the data from Quandl. And please just take note of the dimensions of this table because it will become clear in our next step. So step 2 of the machine learning workflow is to pre-process data. So this is probably the most important step of the entire machine learning workflow, because this is where you get an understanding of what your data is doing, and you get an understanding of what you need to do to manipulate your data, and just an overall understanding of your data and how each of the variables behave in relation to one another. There's typically 3 processes involved in pre-processing data. There's data cleaning, data transformation, as well as data reduction. So within data cleaning, you may find that some of your variables or some of the observations within your data set have missing variables or there's missing entries. You may also find that there's noisy data. So there's foreign objects which your PC or your laptop would not actually be able to pick up. So in that case, you'd want to use some machine learning techniques to actually clean up the data and fill in that missing or noisy data. There's also data transformation. So you may find that sometimes your data, you'd want to transform it from one format to another. So an example of this is standardizing your data or normalizing your data. So you'd want to do this so that your variables and your features are comparable and you can compare them on the same metric or on the same scale. Also within data transformation, you can actually extract or introduce new variables and new features just so that your information when you're building your data model or your machine learning model is actually quite complete and more reflective of the problem. There's also a third step, data reduction. And sometimes you'll find that when you extract your data, when you input your data, you have a lot of variables and quite a lot of features and observations. This may lead to your machine learning model behaving inaccurately. So sometimes extracting some of the data and excluding some of the variables and features will make your machine learning model perform quite better or optimally. So for the purpose of this example, we're just going to specifically focus on data transformation. And what we're going to do is we're actually going to create new variables or new features based on the current information or the current data that we have. We're going to do this by introducing 3 technical indicators, and this is particularly momentum, returns, as well as volatility. So momentum really tells us the change or the rate of change of the variables or the financial indicators that we're dealing with. So this will give us a clear indication of how the change in certain variables actually impacts volatility. We also want to look at the return on our Bitcoin market price. And we do this particularly so that we can get an understanding of what is the return that we got on our Bitcoin in a certain period of time. And we also want to look at volatility, or we want to extract volatility on our market Bitcoin price. This is going to be our response variable. And this is essentially what we're trying to predict. So again, I just want to bring to your attention that I'm not going through the code. However, I do want to show you just one function, end-day return. So this is actually a function that was created internally. It's not necessarily a function that is a built-in MATLAB function. It's just something that we had created just for the purpose of this demonstration. So if you would like to find out where this code is actually situated or located within this live editor, you can highlight the function, right-click on it, and go to open, and it'll take you to the exact location within this live script of where it was actually defined. And as we can see, it takes in 2 inputs, the prices as well as the day that you'll be interested in, and it returns the market price returns of that price given the day. So back to our example. So because we're trying to build a machine learning model which will predict the volatility of Bitcoin, we ideally would like to split our data set, our complete data set, into a training data set as well as a testing data set. Now, essentially, the training data set is what we're going to use to actually build the model. But we want to make sure that the performance of that training data set or of the model is actually optimal, and you can use it on many other similar data sets. So we're going to use the testing data set to actually validate and test the performance of this data set. And because we're using time series data, and time series data can be quite fickle, we actually want to split it up in such a way that we don't use information. So in this particular example, we split 2,000 days worth of data into 365 days for our testing data set. And I just want to bring your attention to the table that we see now. So if you see the dimensions, we've essentially transformed our data set from where we had a 2000 by 20 table. We now have a 1149 by 67 dimension table. And essentially we've transformed our data by adding in those 3 indicators which tell us more about the volatility of Bitcoin. Another really important step within the pre-processing step of your data is to get a visualization, or just to get a visual picture of what is actually happening with your training set data. So we've actually plotted a graph. Okay. It's just going to take a while to pop up. but essentially we have plotted a visual image of our volatility across 30 days. So this is our training data set. So we can expect to see certain peaks and certain troughs within our data set. And this is something that we would expect to see when we actually predict the volatility of Bitcoin. What's really nice about the pre-processing step and the visualization step is this is where you can kind of gauge how your data should typically behave. So if you see your testing or your predicted values, when you actually forecast or predict your volatility, if you see it behaving otherwise, you can actually make a mental note that actually something may be wrong. So now that we've actually pre-processed our data and we're actually happy with using our data, we're going to go on and build our machine learning model. So within MATLAB, there's two ways in which you can essentially build this model. The first step or the first way is to code everything from scratch. And typically, if you have a good amount of domain knowledge and your machine learning skills are quite superior, then that's probably the step or the technique that would be preferable. However, if you're a learner and you're not quite sure how or what model would essentially be good enough or fit your data well enough, we use what we call the learning regression app. So for the purpose of showing and demonstrating the power of the learning regression app, we actually used the learning regression app to create the model. So if you look on the top bar of your MATLAB app, there's quite a few options. If you click on apps and you go down to machine learning and deep learning, there's quite a few techniques that we can use within the MATLAB environment to actually implement or predict or create these models. Marco did mention the classification app, so I'm going to work with the regression app since we are focusing on continuous variables. And yeah, essentially this is what you get. So if you can start a new session, you can import a file if you have a file, but because we've defined our data or our training data set on the MATLAB workspace, we're going to actually import that from the workspace. Okay. So essentially, this is what comes up. So we can select the data set. So we've already split our data set up. So we're going to use the training data set to actually build this model. So lucky for us, our response variable has already been defined for us. And because we're dealing with a baseline model, we don't really know what needs improvements. We're just going to add in all the variables and all the features of that data set, and we'll take it from there. If you look on the right-hand side, there's different validation techniques. There's cross-validation, holdout validation, as well as resubstitution validation. These are different techniques or different validations that you would use on your data set depending on what it looks like. Because we have quite a relatively large data set, we're going to use holdout validation. And we can start the session. Okay. So I just want to bring your attention to the different features and the different options that we actually have within this MATLAB regression learner app. There are features, so sometimes you'll find that you have way too many features and you're not sure which features you'd actually like to include within your model. So there's quite a few nice machine learning algorithms that you can use. There's also a model type. So model type essentially has so many different MATLAB machine learning models that you can use to try and fit or to try and create your model. There is also training. My personal favorite is actually the parallelization. You can train your model in parallel, and this essentially just optimizes your computational time. There are different plot functions. So in essence, if you want to get a visual estimation of what your model is actually doing, the predicted versus actual or the residuals, you can have that. Or if you want to, there are quite a few other metrics, but we'll get to that. And lastly, we have our testing and export. And these two tabs are essentially exporting our function or the work that we've done within the learning regression app onto the MATLAB environment. So like I mentioned, if you're not quite sure what model or what machine learning method would actually best be suited on your data, you can literally brute force it. So you can choose a linear model, train the model, you can pick another different model and actually train the model. So we can look at a linear regression model. We can look at a fine tree. So this is typically what we would do if we don't have an idea of what model will best be suited or best fit our actual data. So we can look at a different one. We can look at an all ensemble. We can actually train that. And you can train it using parallel, but just for time purposes, I'm not going to get that started because it does take quite a bit of time to kick in. But if you do play around with that, you'll see that there are certain models that take a really long time to train, especially when you have quite a bit of data. It does take quite a bit of time to train. So using the parallel computing toolbox is actually optimal. So if you look at the model section, there are quite a few models that we've tried. And if you look on the top right-hand corner of these models, there is a metric called the root mean squared error, or RMSE. And essentially that's a distance-based metric that calculates the difference between, or the variation between, your true value as well as your predicted value. So the smaller or the lesser root mean squared error typically signifies an ideal model. So we can clearly see that the boosted trees ensemble is the better performing model. So this is the model that we'll want to choose. However, if you're not convinced, there are still plots that you can actually look at. There's different plots. You can look at a predicted versus actual to actually see the fit and the fit of your model on your testing, and as well as your training data set, as well as a residuals plot. And essentially these different plots just give you a good indication of how the model is actually performing. But once we're happy, we can actually choose the model that we'd like to export to our MATLAB environment, and we can generate the function. So this is the function that we get once we've used the actual learner regression app. And as you can see, if you're not quite familiar with MATLAB or machine learning, or you don't have a lot of domain knowledge, MATLAB helps you sort of bridge that gap, and using the learner regression app is one of those ways. So essentially, this is the program or the code that we've now generated from using the MATLAB regression learner app. So we can save this to our work environment. And one thing about MATLAB is your function name has to match the model or the function script. I learned that the hard way back in the days. Yeah, so essentially once we've saved that, we can go back to our live editor and we can actually call that trained model, which is trained regression model, and we can actually train our data set just for clarity. And we'll get a trained model as well as the validation or the performance metric of that model. So because we've now trained our model, we can actually have a view of the ensemble tree and how it's actually performing. So I just want to pull that up. So if you can see from this image or from this plot, all our variables are quite cluttered and quite scattered together. So you can't necessarily tell how this ensemble tree is performing and how the model generally is predicting our variables or the Bitcoin volatility. So this is the first sign or the first step that perhaps our model could be modified, or perhaps our model could be improved in some way. But to verify this, we're going to actually evaluate the model. So typically there are two ways of evaluating the model. You can look at a visual depiction, or you can look at a quantitative measure. So within evaluating the model, we're going to actually use the trained model that we actually created using the training data set. We're going to use that on the testing data set to predict a set of Bitcoin volatility values. Now, because we trained a model that was quite known, we use supervised machine learning techniques, we can have a visual representation. Just expand that. We can have a visual representation of how our actual versus predicted is performing. So from this, we can actually tell that the orange, which is our predicted, does not really follow the same trajectory or the same format as our true or actual values. So this is one of the other ways that, or another one of the ways in which we can tell that our model is perhaps not performing the way we expect it to, and we could improve its performance. Secondly, we look at the root squared or the root mean squared error. We can calculate that, and we see that it's about 13% variation. So whilst this is not bad for a first attempt, since we did create a baseline model, it does suggest that we can actually improve the performance of this model. So at this point, I just want to bring to your attention that we have gone through the complete machine learning workflow. We've imported data, pre-processed the data, we've built a machine learning model, and then we've evaluated the performance of the model. At this point, we actually have to repeat the entire process. If we're not satisfied with the evaluation results that we've received on our model, we can actually repeat steps 2, 3, and 4, where we pre-process the data, build a new machine learning model based on that data and then evaluate the performance metrics. So I did mention that within the pre-processing of data, there are 3 steps that you can take, and we specifically looked at data transformation. However, looking at the performance of our model, we can probably go and look at different methods of different processes. So one of the ways in which we've suggested is to actually look at data reduction. So from our ensemble tree, or from the plot of our ensemble trees, we saw that there was quite a bit of variables and there's quite a bit of cluttered, crowded trees that were being built. So essentially this is a suggestion, or maybe a hint, that we may need to actually use a feature selection technique to reduce the amount of variables within our data set. So MATLAB has quite a few feature selection algorithms that you can actually use to decrease or to choose which variables would be of use to your actual model. And as a challenge to you guys, I actually suggest that you go and use any one of the machine learning algorithms or the feature selection algorithms to actually generate a new set of variables, which you can then use to train on the on any machine learning model, evaluate its performance, and see if you actually get a better evaluation metric. So I think I'll just wrap up over there, but I do want to say that this example that we've gone through today is actually an example from a MathWorks example, and my colleagues at Opti-Num Solutions, they hold various technical positions. They actually adapted this example for us today. So this is quite an interesting example. There are quite a few ways in which you can actually improve the model. We just went through a simple machine learning workflow, but like I mentioned, within the pre-processing step, there's quite a few things in which you can do to actually improve the performance of the model. So I do suggest that you guys try those out. And yeah, thank you so much.
Thank you, Hazel. Very nice talk and very nice presentation. Let me share a monitor so I can conclude the presentation with the last part of the event, that is about getting started with MATLAB. For all those of you that would like maybe to start using the tool, there are some solutions that you can that I would like to present to you. All right, so last point of this talk, getting started with MATLAB. But before, let me mention that data science is actually everywhere. There is no single solutions which applies to all problem. All problem becomes overlaps. There is, for example, engineer talking with scientist, natural scientist talking with data science, talking with maybe medical doctors, and so on. There is really a lot of overlapping, especially in the more complex applications that we are looking at every day. And what happens is that there are barriers. Data scientists don't always have the domain knowledge to interpret the results. At the same time, domain experts lack technical skills to build models and solutions. So what happens sometimes is a friction. And at MathWorks, with this tool that we have presented to you, with the workflow, with the example of the Bitcoin volatility, we would like to remove friction and have technical gaps which must be bridged in order to put different figures in contact in order to achieve the best possible solution to your problem. One of the things that you can do starting from this afternoon in order to play with the MATLAB is the online training set. This is something that is free available. It can be used from the browser, whatever you have. You can learn by doing, because you will have some task on the left-hand side, while in the center you will have a place where actually write down your code. And at the end of this training, you can also download the certificate provided by the MathWorks training services. Well, this is quite handy, especially for the students which are now in the audience, because they can have this in their CV, or also for other researcher PhD students which are willing to gain some skills. Here there is the full list of training which are free to do, despite that you have or not a license. You can do this this afternoon already. You just need to go on matlabacademy.mathworks.com, and all the on-ramps actually are for free. So let me show you how do they look like. So let me click on the link. Let's open my web browser, and I will be redirected here. As mentioned before, the on-ramp are for free, so you can learn MATLAB with what is called here MATLAB on-ramp. But you can also learn about specific topics. Today we talked about machine learning, so why not have a training about machine learning on-ramp? You can see I did start some days ago this training, and I'm at 6%. It means that you can start and go back whenever you like in order to conclude that. You can do this everything into the browser. So let me touch the cursor. I will be redirected to this page. Just to recall that I'm still into my browser. In this case, this is Google Chrome, but I mean, if you have Firefox or if you have Safari or whatever, it works the same. You will see there are some different chapters. It starts with what it is machine learning. There is a video that maybe you can put up some caption to better follow the talk, where it explains you with this video the basics of machine learning, just to give you a flavor of this topic. And let me go ahead just to show that the video is going ahead. There is a voice that I have muted at the moment. Then you have some of the workflow, some theory. You can recognize some of the things that Hazel has done before, like import data, pre-process your data, then building your model, and so on, like evaluate the model. And after that, after the theory, after the video, you will be redirected to this problem that you have to solve. Here in particular, this code of machine learning will deal with understanding the handwriting of maybe a tablet or something like that. So you will import different letters where the data are stored in TXT files, and you will be guided toward all the workflow, starting with importing your data. You have here the task that we have to do, and this is read your file. There is always an example. So the task number 1, let me copy and paste the suggestion. And then the task about is to read the data stored in the file name j.txt. So let me change here, that's J, it's not an Excel file, it's TXT file. And he wants me to rename the variable with the letter. Here I have data, one here to have letter. And the function that is actually capable of reading my files is called the read table. So I'm ready, I submit, and the system will give me a real-time feedback. Okay, that's perfect, everything is correct. If it was wrong, I can, of course, change the task and the code, and I can go now ahead with the next step. So these are very nice, this kind of training. Take this opportunity, is there for you in order to learn some, let's say, general usage of the tools as MATLAB or RAMP, or maybe if you are curious to domain specific, you can do machine learning, deep learning, and so on. All right, I just want to show you also that MathWorks is really committed toward university. Skills of MATLAB will be very useful in order to speed up your research. As for example, here you can see the some data about Google Scholar results, about MATLAB and Simulink usage, or maybe if you are a student and you want to gain skill, Jonathan Rosenberg, the vice president at Google, mentioned that if you want to work at Google, make sure to be capable of using MATLAB. The usage of MATLAB is quite widely in university from all over the world, including the top 30 ranked university. In case of you are familiar with other programming language, don't be scared, because there is the way to let you ramp up while integrating MATLAB with other programming language or tools, because MATLAB speaks Excel, speaks C, Java, Python. Code interoperability is very important, and you can manage this in a very easy way into MATLAB. For example, here I'm loading Python installation into MATLAB, into a live script, the same that Hazel has shown you before. And then once I have loaded my Python installation into MATLAB, I can start to use the commands and the syntax of Python into MATLAB. Maybe I have some routine that I have written into Python. I want to maybe work together, Python and MATLAB. Well, this is possible. It's possible also the other way around. That is, as you can see here on the right-hand side, work into Python. So we are now into Python, where inside Python you can import the MATLAB engine with the command import space matlab.engine, and then start to use a MATLAB command, this time into Python. So code interoperability. But many systems need to integrate and place nicely together. We mentioned also before that complexity of application is exponentially growing. There is a new figure sometimes, is the solution architect. So the person in charge of building a robust backend infrastructure. Well, MATLAB has built-in interfaces with many systems, data sources, as for example, Cassandra, MongoDB. If your problem are database and retrieve data, there is the way to work with these other software, and also Microsoft SQL Server. We have also integration with business system. We have seen in the previous slide MATLAB integration with Python and vice versa. There are also, of course, other solutions as Apache Spark, Spotfire, Tableau, and so on. And finally, let me mention also clouds, as for example, AWS or Azure. Okay, I will leave you some links to some video series that you can watch at home. The first one is Getting Started with MATLAB, which give you an overview on the tool. And if you're curious maybe to watch some video about machine learning, just click on this link. There are 3 video series for you to understand the way to tackle machine learning into MATLAB with some easy example. Here I want to show you also some other files. You can download this cheat sheet about data science with MATLAB. Again, the training that I have showed you before. And if you want, there is also a Coursera specialization about practical data science with MATLAB. All the information are given here in case of you want to ramp up and better understand the code and the way to use MATLAB within artificial intelligence for different solutions. With that, we are at the end. Let me thank you so much, all of you, for your attention. Thank you, Hazel, for your great presentation of the demo about Bitcoin. Thank you, Professor Harley, Professor Momonia, to Dr. Mba for chairing this session. Thank you so much, and we are here to answer your question in case of there are.
Thank you very much, Marco and Hazel, for this rich and wonderful presentation. Now we are going to open the floor for questions, comments, about the presentation. All right, there is a question from Sami. Between Python and MATLAB, which one is better? Or should we learn both?
Well, let me take this question. I hope that Hazel is fine. Maybe you can add something also, Hazel, after my feedback. Let me also share my experience. I mean, in my point of view, it's hard to say what is better and what not. It depends on the application, and it depends on what you need to do. So, in order to answer Sami and your second question, should we learn both? I would say definitely yes. More skills is always better, because then you can face a problem from different perspectives. The best things of MATLAB is that you can integrate not only with Python, but also with other things. The unique things that MATLAB has is the application to use the possibility to use apps, so application which are user-friendly, which have graphical user interface. So in case of you are solving your problem, you don't need to write 1,000 lines of code. You can use just the apps in order to get first flavor on your data, and then maybe start working on your code. So this is something. And also the integration with other tools as Simulink, which is, let's say, something unique in the industrial panorama. So Simulink is the things that I was showing you before to simulate, let's say, engineering system, physical models, and so on. And in this way, you have just one platform in MATLAB where to use all your workflow, which is embracing different fields, engineering, data science, medical devices, and so on. So, of course, there are different aspects. So yeah, my point of view would be very good to learn both in order to leverage what you need based on your application. And I don't know, Hazel, if you want to add something to this, to my answer.
Definitely. So I agree with you, Marco. MATLAB and Python are different languages. So what MATLAB essentially loves doing is we love integrating both or all these languages, like you would have seen in Marco's presentation. Interoperability, that's something that's really popular, where this idea where we can use a hybrid of both softwares. So there's no saying which one is better. It essentially depends on what you want to do with either of the software.
All right, thank you very much. We have another question from Prof. Nyabasa. Can we use the methods to look at the volatility in COVID-19 data and make informed predictions, maybe?
Yeah, thank you for the question. That's very nice question. I'm very happy to answer to this question. Thank you, Professor Nyabasa, for the question, because I can explain also. Actually, I'm talking to you from Italy. I'm in the MathWorks office based in Turin. Despite it's a very warm day, let me share this story, because yes, you can analyze volatility of COVID-19 data. And actually, this is what happened in Italy. What happened during the last July, last August, so we are talking about July, August 2020, there was a group of researchers at the University of Naples, Federico II, that was using MATLAB and Simulink to understand COVID-19 data. In September, they published their work on a scientific journal, and afterwards, the Italian government called these researchers in order to understand what to do with the second wave, which was happening in September, October 2019. And actually in Italy, also right now, there is a system of colors among regions. So let's say a region is colored yellow if the COVID-19 risk is not so high. A region can be colored also orange or red in case of the risk is larger and larger. And the regulations are based on the simulation which have been performed in MATLAB and Simulink. So Professor Nyabasa, if you are curious about that, please send me an email, because I will send you the video that is on YouTube about this professor that is explaining in a conference in the MATLAB Expo 2021 the usage and also the influence to the Italian government that actually was taking this simulation to design actually the system which regulate the COVID-19. So absolutely yes, and thank you so much for your question.
Okay, I have a question. In the demo presentation, there was a code that we can use to get the data from Quantum, knowing the API key. I would like to know, through MATLAB, can we get the data, let's say, from Binance, from Coinbase, because those are the cryptocurrency exchange market. And from those websites, we can have a live data to exactly know what is going on exactly from the market. is it possible if we can get with the API key from those exchanges, can we get data to MATLAB to use for simulation?
So I'd like to take this question. Marco, you can also add in, please. But essentially, there is a toolbox, library, if you will, that particularly focuses on extracting data from numerous platforms. I'm not sure if the ones that you mentioned are included there, but it is worth having a look, and I can look into that and get back to you. But MATLAB does do a lot of web API or a lot of data pulling using web APIs.
Okay, thank you.
Yep.
All right, we have a question for Stephen Allied. You mentioned MATLAB is common in education and research sector. I can see MATLAB is very heavy to install. Is there a toolkit to deploy solution with light version of MATLAB?
I will answer your question. Yes, there are two possibilities actually to use MATLAB. The first, as you mentioned, is to download the software and to install to your laptop. But let me show you also another solution. So I hope you can see my monitor. I'm in Google Chrome at the moment. And what do I do is to go on this website that is called the matlab.mathworks.com. I'm in the browser, so I didn't do any installation. I didn't do anything. And for example, here I will have my MATLAB page, and I have some files which I have in my MATLAB cloud folder called MATLAB Drive. And I want to open one of them. It's called Olympic Analysis. What is about? Let's see. So actually, you see the same environment that Hazel has shown in her demo, but now I'm using MATLAB from the browser. So it means that your students, your researchers don't need to download anything. Actually, they just need to go on the browser, type matlab.mathworks.com, and start to use MATLAB from the browser. Here I have a file that I can run, that I can check. For example, here it's relating the Olympic medals of the Olympic Games. This was the Olympic Games from the summer 2016, so was those in London. No, sorry, it was in Rio 2016. And they are connecting the number of medals to the gross domestic product of each country involved. So you read an Excel file. As you can see here, I'm running my code. I have my Excel file here. If I run this code, what happened is that in the workspace now will appear some variables, which are those loaded by the files. So I have the medals, I can explore this. I can plot. Now here there is a geoplot with some bubble, which show me that, yeah, maybe there is a great correlation in the United States, maybe UK, Russia, China, and maybe I can double check also my data to get a better understanding. So I have all the countries, I have all the medals. I mean, what I can do is maybe to select the column of the countries, which is different, by clicking on the column itself, and then on the column of the medals. And you can see into the browser, I can use MATLAB. Maybe, I don't know, I want to plot this information like golden country with the work cloud. And what I do is to plot these. I mean, there are also many other plots that I would have used, but here I can check United States, United Kingdom, Russia, China. That is also the bubble plot. So that's a text analytics. So just to say you in short that yes, you can do this with MATLAB online, and actually you can do this actually without installing anything.
All right, thank you. Yes, yeah, go on.
Yes, Amanda, you are deploying the solution to an embedded system. Yes, definitely. Also, to answer to this question, Stephen, Arduino Raspberry Pi nicely integrate with your MATLAB. Actually, you can have a code of artificial intelligence and maybe have a sensor on Arduino, I don't know, which is connected to Arduino, a temperature sensor, and maybe plug in your code to do, I don't know, something like that. ontology on RDF. Let me double check this. I want to be precise. So in case of, let me double check ontology or RDF toolkit. Most likely, if MathWorks has not developed that, there is the community that has developed that. Because if I go on the MathWorks website here, and I go, this is the website, you can access this every time. There is the file exchange, that is the place where researchers, students share their code. And if I write RDF, maybe I got, I don't know, some kind of information, a code example that I can download. So, but let me follow up on this question properly. After that, please send me an email, and I will provide you proper answer on that. I don't know, Hazel, if you want to add something.
Thanks, Marco. I think you've hit all the points. We can just double check.
Yep.
All right, thank you, Dr. Rossi. Any other question? All right, if there is no other question, I would like to thank our two presenters, Marco and Hazel, for this wonderful presentation. We have learned a lot, and we have your emails. Yeah, we can always contact you if we have any additional clarification. And I would like to thank Prof. Ali and Prof. Moniak for giving me the opportunity to share this seminar. Thank you very much.
Thank you all. Thank you so much.
Thank you very much.
So much.
I just want to thank the speakers, and actually, Jules, before we go, I just also want to remind everyone of the Data Science Across Disciplines Research Group's next seminar, which is actually happening this coming Monday. It will be by Siddhartha Mishra, who will be speaking about deep learning and computations of high-dimensional partial differential equations. So if anybody's interested, please do join us. And thank you again, Jules. We really appreciate you chairing today, and thank you to our speakers once more.
The University of Johannesburg, the future reimagined.